this video, we're going to explore change of velocity, but in this case, it's going to be in 2 dimensions. So we've got a baseball thrown horizontally to the ground at an initial speed of 23 meters per second. The batter hits the ball, so it departs the bat directly vertical at 33 meters per second, and we're going to calculate the change in velocity. So let's put down our vectors first. So here's our initial velocity, and it's going at 23 meters per second. There's our baseball. So that's u. Now we'll put in our final velocity v, which is basically going to be going vertically directly to the ground at 33 meters per second. Alrighty, so now what we've got to do is put our algorithm down. Now our algorithm, as we know, is delta v equals v minus u. Now the diagram to the left basically shows us all the forces that we've got, all the vectors we've got. U plus v is going to be, of course, a change in velocity, delta v. So we put down v, then we put down negative u, which is going to be 23 meters per second. We produce a right-angled triangle, and the dotted line is basically going to be our resultant at an angle to the ground. Now the angle that we know we will call theta, but we're also going to find this angle here, which is going to be x. That'll be the horizontal angle to the ground. So we know that delta v equals the square root of v squared plus u squared. So in this case, we get 33 squared plus 23 squared. Now the minus doesn't matter because we're squaring it, so we end up with 40.2 meters per second. So that's our resultant. So let's find the angle. Now the angle will be made up of tan, which is basically opposite over adjacent, which is 23 over 33, which gives me 35.9 degrees. But that's not the angle I want. I want the angle to the horizontal, which is 90 minus this value. So that gives me 55.1 degrees. So my overall change in velocity for the baseball is 40.2 meters per second at 55.1 degrees to the horizontal. Okay, I hope that makes sense. Thanks for watching.